actually I'm on the program today, both under the auspices of VaasaETT, which is a consultancy run out of Finland, working internationally, and then also the Smart Energy Demand Coalition, of which we are the executive directors. So today I'm going to be giving you actually an introduction to the Smart Energy Demand Coalition, and then tie that in with some research which they have been involved in, but which VaasaETT has actually conducted in cooperation with our research partners. So first of all, what is the Smart Energy Demand Coalition? Okay, it's a not-for-profit industry group representing the needs of active demand in Europe. So that's everything we've been talking about today, basically. Feedback, automation, dynamic pricing. How do we get consumers involved, and what is needed in Europe, technologically and then also regulatorily, to enable that involvement? We started last year, so we're actually basically exactly a year old. And I think the list of our members speaks to the industry level, the interest level there is in the industry right now. We have purposely really made an out-and-out effort to have a member group that really represents the industry, because what we wanted to avoid was just to represent the interest of technology providers or smart meter manufacturers or network companies or whatever it ended up being. So the members represent the full spectrum of the energy industry, and our aim is to look at the status of this industry and how we as a group, we as a community, can move it forward. So let me look a little bit at the content of this presentation. I was looking at the program and saw that I had promised to give you a presentation covering a project we did last year at VaasaETT involving some 450,000 residential consumers, looking at demand response and their potential for demand response. So I will be doing that, and then I will also be tying it into what does this mean in our markets, because what we tend to do is we tend to see pilots as an end in themselves. We do a pilot, it's a good pilot, it works well, we learn something, and then we're pleased, which is fine, but we haven't actually done anything. It's nice, it's a step. So what I want to try to do today is make the jump and say, okay, if we did this, when we do this, what does that mean in the markets? What's the real potential of residential consumers, commercial, industrial consumers in the market today with what we've got, with our real technology, with the regulatory structures we have? So, smart grid. What makes the smart grid smart? We all know the answer to this question, but everybody answers it slightly differently, so I'll give you our view of that. Basically, the grid as we have it today is very one-directional, and the generation supplies demand. Demand doesn't do anything for generation, and it doesn't do anything to help the efficiency of the grid. And so you can look at the smart grid and you can say, oh, there's wind, there's fuel cells, there's cars, there's CHP, there's all these wonderful things. But the thing that's making it smart is the interaction. It's the interplay between demand and generation cooperating in an intelligent, holistic manner. Without that, it is not smart. It's automated, there's more pretty technology out there, but the cooperation's missing. The intelligence is missing. And that's, of course, why consumers, from here on out, as we develop this grid, will become part of the basic infrastructure. And I think if we have a vision at VaasaETT, but then also especially in the SCDC, it's to take consumption from being this sort of smart, futuristic, luxury resource we pilot to really becoming a central, just as central as your gas-fired power plant, your coal-fired power plant, your transmission system, just part of the picture, part of the cooperative picture. So what, in these pilots that we've compared, so what did we do? ESMIG, very courageously, sponsored us to do a very large comparison, sponsored VaasaETT to do a very large comparison of 100 pilots involving 450,000 consumers to see what happens when you do these things over and over and over again. What are the results in an effort to make them as robust as possible, given the current circumstances, what we live in. So we had these pilots, we broke them down into 460 samples. They came from around the world. A little under 50% came actually from Europe, especially the feedback were mostly European. And we tried to see what we would come up with. So feedback pilot comparison, you've seen comparisons like this. We took in-house displays, invoices, web pages, and other could be looking at washing machines or whatever, giving very specific feedback. As you can see, the most effective was some form of direct feedback, directly going to the consumer in some form of display. That doesn't mean it was on the wall at a classic in-house display, but it was some form of direct feedback. I'd like to add that that's the international average. The average in Europe was 10% reductions. Actually, European consumers can score consistently higher than a lot of the rest of the world, which is interesting. Australia and Japan can sometimes do better, but overall we are definitely at the top end. Okay, time of use. Here is the dynamic pricing, the potential for peak clipping. What would consumers be able to do in order to help integrate wind generation, for example? Smooth out curves so we can take away some of the unnecessary aging power plants we save to supply those peaks. Time of use was between 5 and 15%. So the green, for those of you who can't read at the back of the room, the green is with automation in the home, and the yellow is simply through consumption behavior changes. Remember that this is not total consumption reductions. Something's taking off. Sort of symbolic. This is not total consumption reductions, it's shifting, right? However, it's impressive. I mean, critical peak pricing, 31% consumption shift with automation. 16% simply through behavioral change. That is a big change. You take 16% of your residential peak off in France, for example, and you've basically, that's most of the peak, because most of the peak is residential. Okay, so here's an interesting thing that we were not expecting to find. It brings out the importance of communication with consumers. We all like machinery, and so the temptation is just to automate it, put in enough machinery, and we no longer have to communicate, we no longer have to think anymore, we don't have to change our behavior, it'll just happen by itself. Well, to a certain extent that might be true, but I think these findings are interesting. If you just do time of use, and by the way, it was the same for critical peak pricing, if you just do dynamic pricing and automation and you don't communicate, the total consumption results go up. People consume more than the comparison group. And I think the reason for that is if it's so cheap for most of the time, you just quit worrying about it. It's the opposite of what you'd actually want. So it brings out the importance of combining. In fact, one of the main findings of this entire research was that more is more. Different types of feedback, combined with prices, combined with automation also is helpful. So, but what I want to leave with you here is that really the communication, the involvement of the consumer is very, very key, even when you have automation in the house. And especially when you want to have a successful rollout, looking at now we're going to make the jump to national. Getting people involved is very important. So that was a very quick overview. The research itself, if you're interested, it's a public study. You're welcome to download it. It compared 22 different variables, so there's lots there that was not included here. And it was quite in-depth. DG INSO funded VaasaETT and PODU and Oxford University to do a research project on the potential of the smart grid to lower total consumption and greenhouse gas reduction. So I'm going to combine now and give you both of these because we use the results I just gave you as the basis for this research, or a basis. So what can the smart grid deliver? Making the jump, making it real, what are we looking at? Okay, just to kind of, oh, did this again, I don't understand. Anyway, PDFs, it doesn't happen. Just to kind of do, we started with a very realistic picture. We went through every country. We were supposed to do Great Britain, France, Germany, Spain, Austria, and Portugal. We really looked at, are they going to enable feedback? What's the rate of their smart meter rollout? This was a goal for 2020, so by 2020, how much wind are they going to have? What's the state of their transmission system? What's the frequency of their cross-border trades? PODU has very, very good data. It was done on an hourly basis, 8 years worth of wind intermittency data, so very robust. I'm going to skip this because it's too detailed, but you can look at it if you like. Basically, what's interesting to see here is you start on, I probably won't be able to make this work. You start on that side with, say, a 10% reduction on your pilot. And by the time you've done uptake, the level of smart meter rollout, the level of capabilities in the meter, you're down to things like 3% total consumption reduction. And if you don't do smart meters or you don't have the feedback capability, down to 0.05%. You get to see that every capability in the market has a direct knock-on effect on your end result of your smart grid. Sometimes we tend to look at these things in isolation, like it doesn't matter. But what's very interesting with doing research like this is that you see, no, they don't have smart meters, or their meters aren't capable of communicating into the home, and therefore they're not going to be doing this, and they won't have those programs, and they won't have that benefit. And you sort of see the chain reaction. So, taking in everything, the total consumption flexibility potential, we did expected and feasible. None of these scenarios are idealistic. We only took things that were completely technically possible within the range of what consumers were able to do the whole bit. And what the big difference between the expected and feasible scenarios were really the regulatory structures and the plans that the utilities have in these different markets. As you can see, in flexibility, Germany is set to have the widest gap, actually even more than Portugal, for example, or Spain, or they expect that a little bit. But Germany is set to have the largest gap, and that's because they are, in their current plans, leaving consumers out of their smart grid rollout plans. They're only enabling consumers with 6,000 kilowatt hours a year consumption and above. Their commercial industrial demand response is very difficult to get off of the ground. It's very complicated. It's a difficult market to enter. And you just see it very sort of hands-on in these pictures, that if you have all this automation, you have all this stuff, but you're not bringing your consumers with you, you simply will not get the same results as an economy with theoretically a lot less technical capabilities, but who are making that, bringing the consumers with. Here you have the energy savings, total energy savings for the market, what is feasible, and then what is expected. You can look at these. What's to keep in mind here is, say you have that you enable your residential consumers to lower consumption by 5%, which would be a very, very good result for a national rollout. If they are 30% of the total national consumption, they are lowering national consumption by 1.52%. Do you see what I mean? So this is taking into account the entire national consumption. And then just for your interest, and I'll end on here, greenhouse gas emissions. This was the change in emissions in megatons of CO2. What is the potential and what is expected in the markets? Again, you can see that Germany has a very large gap, and you can also see that Great Britain, who is really planning to activate their consumers, are going to be reaching really what we saw was their feasible goal. Because they're bringing people with them, you can see it in the results. Okay, so main conclusions. Interesting, most savings and flexibility right now, because of the effort being put into the segment, are going to be delivered by residential consumers. This does not match, industry is 30%. Commercial buildings are 27%. They're almost nowhere here. And talk about new market, unexplored market segments. Definitely that would be one. And above all, the results demonstrate the potential power of consumer communication, of tapping into and using what we want through smart grid technologies and what we're able to produce. Thank you.